If we're going to be studying matter and its changes, we probably should spend some time talking about what matter is and what those changes are. So, first of all, it's important for us to think about the types of properties that we're observing when we observe matter, when we engage in a scientific process. So, physical properties are usually things that are a little bit more on the macro scale. They're bulk properties, things like the mass of an object or the size and the shape of an object. When something undergoes a physical change, we're not changing its chemical identity. We're not changing what it's made of. We're just changing its bulk behavior. So we can bend a wire, we can melt water. It doesn't change chemically what we're working with. Chemical properties are the properties that are responsible for or are caused by the way something is chemically assembled on a microscopic level. When things undergo chemical change, we're actually changing how things are put together down on that microscopic level. So when something like methane, for example, burns, burning is a chemical change. When methane burns, it's no longer methane. We've changed its chemical identity to carbon dioxide and water. When we're looking at types of matter, that's another way we can classify what we're working with. So substance is matter that has the same chemical and physical properties throughout. So it's sort of a generic term, but let's make sure we define it. When we're classifying substances, we can classify those substances as either being an element, which is a substance that cannot be broken down into chemically simpler components, or a compound. So elements, no matter how much we subdivide them, no matter how much we tear them, no matter how much we break them apart, they're always the same building block unit, and it can't be broken down into chemically simpler things through chemical change. A compound is a substance that's made from two or more elements, and it can be broken down into chemically simpler compounds by undergoing chemical change. So water's my favorite example because everybody knows that water is H2O. It's made of hydrogen and oxygen. We can break water down into hydrogen and oxygen. It's a compound. What about mixtures? Well, a mixture is any combination of elements and compounds. It can be all different elements, it can be all different compounds, it can be a mixture of elements and compounds together. We classify mixtures as either being heterogeneous. Heterogeneous mixtures are things that have differing composition depending where you sample them. So I've got things like fried rice here. It's a heterogeneous mixture because one little forkful might just have rice in it, one might have some egg, one might have some peas or some onions. It's heterogeneous. Homogeneous mixtures are the same no matter where you sample them. So homogeneous mixtures, often called solutions, are things that are fully dissolved and separated. So something like sugar dissolved in water. If you dissolve sugar in water, you're not going to sample it drink out of one side of the glass and get a whole bunch of sugar, drink out of the other side of the glass and get a whole bunch of water. The composition is the same throughout. Now, we mentioned both physical and chemical changes. One of the most probably common physical changes is going to be phases or states of matter. Phase and state mean the same thing. They're interchangeable. So we can certainly classify things as solid, liquid, or gas, and one way we can define those, and we're going to look at a couple ways to define solid, liquid, and gas throughout the course. But one way to define them is that a solid is something that has a definite shape and a definite volume, right? So my coffee cup has this shape and this volume. It doesn't matter where I set it, as long as I don't drop it on the floor and break it, it's going to have a definite shape and volume. And even if I do break it, it still has a definite shape and volume. I'll just be sad because I broke my coffee cup. A liquid has a definite shape or has a variable shape, and a definite volume. So a liquid will adopt the shape of its container. Right? You pour water. If I pour water into my beaker coffee cup here, the water will take on the shape of the beaker. If I pour that same water into my regular coffee cup, now it'll take on the shape of my regular coffee cup, but the volume is going to be the same. And finally, a gas is something that has the shape and volume of its container. A gas will expand to fit whatever container it happens to be. So remember, when we're talking about phase changes or state changes, these are physical changes because we're not changing the chemical identity of the substance, we're just changing the phase or state that it exists in. So here's a handy little flow chart for classifying substances. If there's only one present, then it has to be either an element or a compound, depending on what it's made out of. If there's more than one substance present, it's some sort of a mixture, either heterogeneous or homogeneous, and all of these can be either solid, liquid, or gas. So often, one trap that we often fall into is we think about a homogeneous mixture, we think about a solution, and our brain immediately goes to solid dissolving in liquid. But you can make a solution from liquid dissolving in a liquid. You can make a solution from a gas dissolving in a liquid. And in fact, you can make a solution from all gases, right? The air we're breathing is a solution. It's a mixture, a homogeneous mixture of nitrogen and oxygen and a bunch of other things. Similarly, you could have a solid solution. Things like brass are solid solutions. So don't get too locked into liquids when you're talking about homogeneous mixtures. Good luck. We'll see you on the next one.